Hey guys, I wanted to prove for you the formula that I showed you last time. And so that formula was the formula for a dot product, and what it said was that v dotted with u is equal to the length of v times the length of u times the cosine of the angle between them, cosine of that theta. So in order to do this, I want you to consider v and u on a coordinate axis here on a Cartesian plane, where I'm going to draw v in red. So this is our vector v. I'm going to draw u in green. So this is our vector u. That should be a straight line. That is a straight line. Might not look like it is, but it is. And here in black is this angle in between them. That's that theta. And so I want you to look at one more vector. And what that vector is going to be is this blue one here. And this vector is v minus u. If you don't recall that, then you should look up vector addition and subtraction. It's a very simple thing to look up and a very simple thing to do. But this vector here is v minus u. Okay, so from the law of cosines, which is another thing that you can look up and not something that you generally need to have memorized, but what it says is that the length, this is law of cosines, L-O-C, law of cosines, says that the length of v minus u squared is equal to the length of v squared plus the length of u squared minus 2 times the length of v times the length of u times the cosine of theta in between them, times cos theta. Okay. Well, this is pretty helpful actually, this law of cosines. So, what we can do now is we can look at this term here, and using the property that I proved for you last time that says that any vector, so I'm just going to call the vector x dotted with itself, dotted with x, is equal to the length of that vector squared. Well, if we, instead of using x, use this vector v minus u, then we can substitute this in. We can use this property here that I actually proved for you last time in order to prove this new property for you. And so what this is going to say is that this red circled term is equal to v minus u dotted with v minus u. So then that's going to be v minus u dotted here with v minus u. And I'm just going to ignore the right side of the equation for now. I'll come back to that in a little while. And what I want to do now is I want to FOIL this out. So I want to have v dotted with v, which using the same property in red is just the length of v squared. So then it's the length of v, this left side of the equation becomes the length of v squared minus u dot v. If we FOIL here, it's going to be minus u dot v and then minus another u dot v. So minus 2 u dot v, minus 2 u dot v, and then we're going to have a plus u dot u, or plus the length of u squared. Well, alright, let me rewrite this all for you, and then we can cancel some terms, and it'll be pretty simple, as a matter of fact. So, here we go. So we have the length of v squared minus 2 times the vector v dotted with the vector u plus length of u squared, and these are vectors, equals the length of v squared plus the length of u squared minus 2 times cosine of theta, running out of space here, but this is 2 times cosine of theta times the length of u times the length of v. Okay, well, right off the bat, we can go ahead and we can subtract this term from both sides and get rid of that. And then we can do the same thing with this term. We can get rid of these terms as well by subtracting them. And we can also divide then by a -2 in order to cancel this term and this term. And so what we're going to be left with is that, as I had said before, v dot u, v dotted with u, is equal to the length of v times the length of u times the cosine of the angle in between them times the cosine of that theta. And if you don't see this, then maybe you can rewind the video, watch it again, or if it's just some little algebra technique, then you can start from this equation here, if you believe me on that, and you can work through it yourself. And it should be pretty straightforward, because yeah, this is a well-known property of dot products, this right here, and this is actually a very useful property of dot products, because it can be used in given 2 vectors to tell you what the angle in between them is, or if you're given one vector and here, so that u is a vector as well there. If you're given one vector and the angle in between them, then you could find the length of the other vector. I think you could do that. Let's see, so if you had vector v and the angle in between v and u, actually you might not be able to do that one, but given 2 vectors you can find the angle in between them very easily. And it can also be used to solve for the lengths of vectors as well. So yeah, like I said, this is a good property to know. And if you don't have it memorized, well, it's a good property to be able to look up and to know at least that you should know it. And yeah, next time I can talk to you about either cross products or projections. So I hope you guys have a nice weekend, and I'll see you later.